Okay, so where we left off in this section, we finished the arc length. And so now we want to look at the surface area of revolution. The formula that I am going to come up with is as follows. S is equal to the integral from A to B of 2 pi times the radius. And then that thing in there is the length. Now, where does that come from? Okay, so let's think about this. So here we have a cylinder. And this cylinder, as you can see, I have this line L. So if I take this line L, where is my L? And I take this line L right here. That is not going to do what I wanted to do. This needs to do it the way I needed to do it. If I take this line L and I rotate it like this, okay, just take that one line and sweep it out, I'm going to get a hollow cylinder. Okay, so this is a hollow cylinder. And I can talk about surface area, like the surface area of a soda can. That's it, just the surface area. So the surface area is the amount of that it would take for me to use of this thing in order to be able to cover it in maybe aluminum foil. Okay, so I know that I'm going to have the length L, that's this length here, but then when I cut it right along this dotted line and open it up, then this line right here, so this line right here becomes this line right here. So that is the part. In order to find that height is 2 pi times the radius. Why? It's the circumference of the cylinder. So this is the circumference of that cylinder. So then I can talk about the surface area, which is just this area. So that surface area is 2 pi r times the length. Okay, so that part is easy. So now let's look at this. So suppose now we have something that looks like this. Oh, I want that to be black. We have something that looks like this. And so now I'm going to take this line So now I want to take that line and I want to revolve it around the axis. So when I take that line and revolve it around the axis, I end up with something that looks like this. Okay, so when I revolve it now, I get and then I'll revolve it here. Okay, so I get something that looks like that. Okay, so kind of looks like a bullhorn. Now, we already know how to find the length of this curve, okay? Whatever this curve is if this curve right here is, get rid of that. If this curve right here is y is equal to some function of x, then I know the length of it. That length right there, well, I know how to find that length. The length of that piece is the square root of 1 plus dy dx squared. So therefore, I'm going to put that L in the place of the L above the other problem. So therefore, okay. So therefore, when I go to look at this one, I get that the surface area is the integral from A to B of 2 pi times the radius, but this time the length happens to be this formula, the square root of 1 plus dy dx squared dx. Okay. This should have a dx out here. Okay. All right. So that's the length. All right. So now we can talk about the surface area of revolution. So that's the surface area of revolution about a horizontal line. Okay. Or about the x-axis. All right. So we get these two now. So we get this formula. So for the surface area of revolution for a line y equals f of x rotated about the x-axis, we get this formula. The one I just did, which is S, surface area, is equal to, some people just write A for area. I write A or S, it doesn't matter. We can write SA, surface area, is the integral from A to B of 2 pi times the radius times the square root oh, that's cute. Of 1 plus, and then some people will put here 2 pi r. Usually r is the radius. So a lot of times you will see this formula. I'm going to rewrite it. 2 pi y of x, the square root of 1 plus, and then you might see y prime of x squared dx. Okay. So you will get that. So that's the formula for the surface area of revolution. All right. Okay, of course, we can always rotate it about the y-axis. All right. So we can have the surface area of revolution, the line x equals g of y. I know y'all don't like that. I don't know why x equals g of y just always feels so weird, but that's okay. Rotate it about the y-axis. So of course, that's going to be an integral from C to D. All right, so that's just going to be S. And I'm going to do a couple of these. Is going to be the integral from C to D of 2 pi. This time you'll see x of y, the square root of 1 plus x prime of y squared dy. So these are our two formulas that I'm going to highlight that we're working with. Here's the other one. I will highlight it. We are working with these two formulas. Okay. All right. So our first problem is Find the area of the surface generated by revolving the curve y is equal to 2 times the square root of x on the interval 1, 2 about the x-axis. Okay, so we're going to draw this. All right, so let's draw it. Oh my goodness. Okay. So 2 times the square root of x looks like this. Okay, we only want the region between x equals 1 and x equals 2. So that would be between here 1, between 1 and maybe 2. So we only want this part. Okay. So we're going to get rid of this because we don't need it. All right, so that's the part of the curve that we want. All right, between x equals 1 and 2. So we're going to revolve that around the x-axis. So when we do that, we end up with something down here that looks like this. Okay, then we will revolve our points. So we'll get this. So this is going to revolve around here like that. All right, so kind of get this and move this a little up a little bit. It's not too bad. And then we will rob this. Uh-oh, nope, that's not, now that was bad. Okay, let's try it again. It didn't recognize my shape. It was so poorly drawn. Okay, there we go. It recognizes it now. Okay, so this is my, so you can see here, the area, the surface area. So the area is that thing. It's just the outside shell. Okay, there is no inside because this thing is hollow. So it's just the outside shell. And so I need to find the area of this. Okay. All right. So how do I do that? Well, I can see here that this part is what I'm going to be finding the length. So this is my length L, which is there. Okay. And the radius, which would be this is the radius. So for us, again, the radius, if I choose any X value, then the radius is just the Y value. So that goes up to here. And then it goes all the way over to some Y. So for any given X, that radius is Y, but I know that Y of X is equal to 2 times the square root of X. So therefore, that is Y of X is equal to 2x to the 1/2 power. So actually, that's a really nice problem because Y prime of X, which I'm going to need, is simply X to the negative 1/2. Okay. All right. They gave me the integral 0, 1. So I'm set right now to do this. All right, we're set. Let me leave it so y'all can still see it. So my surface area, S, is going to be the integral from A to B. So that's going to be from 1 to 2 of 2 pi y, which is 2 times the square root of x. And then I'm going to need in here the square root of 1 plus y prime of x squared dx. So we're going to do like we did before. We're going to simplify this thing first. Because if I don't simplify that, I got a mess trying to simplify it in my integral. Okay, so we found y, we took its derivative. We're going to do y prime squared y prime squared is just x to the -1, which is just 1 over x. 1 plus y prime squared is 1 plus 1 over x, which I'm going to simplify as x plus 1 over x. Okay, and then I can take the square root of it. So the square root of 1 plus y prime squared is just a square root. There's nothing special about it, of x plus 1 over x. Okay, so now I get that surface area S, it's the integral from 1 to 2 of 2 pi. I have 2 times the square root of x, and I'm going to put this thing in as the square root of x plus 1 divided by x. Well, that really is rather nice because this term simplifies. So this becomes S is equal to, here's my algebra, guys. I'm going to write that as 4 pi. I have the square root of x, but this now becomes the square root of x plus 1. Here's the algebra over the square root of x. Yay, how nice that is. Those two things are going to divide out. So now dx. So this is S, is the integral from 1 to 2. I may as well pull the 4 pi out. Let's get rid of it. Let's make it outside. The integral from 1 to 2 of literally just the square root of x plus 1 dx. Okay. All right, so this is a very simple integral. U is equal to x plus 1 du is dx. When x is equal to 1, u is equal to 2. And when x is equal to 2, u is equal to 3. So this becomes S is 4 pi. 1 becomes 2. 2 becomes 3. This becomes u to the 1/2 power du. Okay. And this as an answer gives me 8 over 3 pi times 3 to the 3/2 power minus 2 to the 3/2 power. Done. Okay, any questions?
I have a question.
Yes.
I don't get the point when you did, I don't know how, like, if you could scroll up, I'll show you. Keep going a little more, like on the right, where you did the prime and all that. Like, can you just explain, like?
Oh, no problem. Okay, so this is 2x to the 1/2 power, right? So when you take the derivative, you're going to have y prime. So y prime, you have the 2 there. You're going to bring the 1/2 down.
No. I know how to find it. I just, like, where is it coming from? Like, when you do the x and the y, I don't get, like, why, like, I don't know what I'm trying to ask.
The formula, maybe?
Like, I feel like I would skip that step. Like, I don't know why we have to.
Okay, we need that step because we need to find this. This is
okay.
That's the same as before. The book tends to write it differently. Let me write it another way. Maybe it'll help you. Okay. I'm just going to write it a different way. See if this helps. So if I write S is equal to the integral from A to B of 2 pi, this is y of x, and then I write in here the square root of what we did before, 1 plus dy dx is the same thing, squared. I don't know if that helps, dx. So the y prime is the same as the dy dx, but what we did earlier this week, let me go back, when we were trying to find the area of a simple curve, the length, I'm sorry, not the area, the length of a curve, we were able to show that the length of the curve came out to be just this piece. So it was the square root of 1 plus, remember we had these steps. We identified y, we took the derivative, we squared it, we added 1 to it, we simplified it, then we took the square root and then we integrated it. That's what I did here. So here, I started with y, I found its derivative, I squared it, I added 1 to it, and then I simplified it, and then I put it inside the square root. Peyton?
No, I get it now. I just forgot about the equation,
No
the
problem.
new one.
You see
Yeah.
this? Yeah, you see the steps now?
Yeah.
Okay, all right. Anybody else not seeing the steps? Because this is really important. Okay, we're going to do another one that's almost just like this one. Whoa. Okay, so on these next ones, I'm going to do the setup, but I'm going to skip the integration. All right. Hang on 1 second, please. Just hang on 1 second. Okay, so now let's do this problem. So we have the arc of y is equal to x squared. On the integral 0 to. So y equals x squared looks like this. And so on the interval 0 to, this height would be 4. So let's make that a 2. And then we're going to revolve the same arc about the x-axis. So when we do that, we get this. And then when we go to draw our, it's kind of hard to draw, but we got it. Let's make it much smaller. Wow, it sure lets you know how bad your plot is. This should not be here at all. This should be way down there. Okay, there we go. Much better. Okay, so when we revolve that, we do get something that kind of looks like a horn, but it's not really because there's no space to blow out of it. But I can see the surface area is the outside. So if this were a horn, I would need how much metal do I need to make this thing? That's what we're asking. The surface area. Again, this thing is hollow. It's hollow in here. So I'm only talking about the area on the outside. Okay, so this is a fairly easy problem. Again, We know our formula. If you guys want me to snatch it and grab it, I will. So let's snatch and grab, just so we have it down here. Because all we need to do when we get these problems is fill in the parts. And they told us A and B, so that was good. Okay, so now we know A and B, that's 0 and 2. We know y is equal to x squared dy. So dy dx, that's 2x. Okay. All right, we need to square it. So dy dx squared, that's 4x squared. Okay, we need to add 1 to it. 1 plus dy dx squared is 1 plus 4x squared. Now I can't simplify that anymore. That's the best I can get. Okay. And then I need the square root of that. So the square, it doesn't simplify, so I'm just going to put it in. So the surface area is the integral from A. I know A. A is 0. And B is 2. I get 2 pi. Y was x squared. And then I get the square root of 1 plus dy dx squared, which is 1 plus 4x squared dx. And that's the integral. Now, you guys, I have not taught you how to do that integral yet. We will learn how to do that integral later. Okay, actually, that integral is not hard now that I look at it. Oh yeah, that integral, we need some more stuff to learn how to do that integral. Okay, next problem. So if you get one of those set up but do not solve, I literally expect it to take you 2 to 3 minutes to do it, because all you have to do for setup but do not solve, maybe a little bit more, because I'll give you opportunity to draw the picture if you want. But then you know 2 pi, you know what y is, you know how to do the derivative, you know how to square it, you know how to add 1, stick it inside the radical, and there you go. Set up but do not solve, on to the next problem. Okay. Find the area of the surface generated by revolving the curve. X is equal to y plus 2, the square root of y, between 1 and 2 about the y-axis. Okay, so we're going about the y-axis. Okay, so I need to know what this looks like. We can graph it. It is x is equal to y plus 2 the square root of y. I did tell another student, for things where you need the picture, I'm going to try to put the picture in the test so that you're not doing too much with the graphing, because if it's that part, I don't want that to hold you up on the learning of calculus 2. Okay, so we're moving this thing about the y-axis. Okay, so we're getting something that goes about the y-axis. Okay, so it looks something like yeah. Even if we don't know what it looks like, I'm going to draw it anyway. It's not really necessary for this problem. Actually, yeah, I'm not even going to draw it because it's not necessary. Let's just do the problem. Okay. So this problem is going about the y-axis. So therefore, I have x is equal to g of y. So now I have x g of y, 1 less than or equal to y less than or equal to 2. So this is easy. C is 1. D is 2. X is equal to y plus 2. The square root of y, I'm going to write as y to the 1/2 power. Okay. So dx dy, otherwise known as x prime of y, you take the derivative of that, you get 1 plus y to the negative 1/2 power. Okay. All righty. We need to square that thing. So we get dx dy. Notice I'm just following the rules. Right now, as I'm doing this problem, I don't know any more about this problem than you do. I'm literally just following the steps. Find x, find its derivative, square it, add 1 to it, simplify it, put it in the radicand, stick it in the integral. Okay, so this squared is 1 plus y to the negative 1/2 squared. We're going to FOIL that. And we're going to get 1 plus 2y to the negative 1/2 power plus y to the minus 1. Okay, so we FOILed that. Let's add 1 to it. So 1 plus dx dy squared is 1 plus 2y to the negative 1/2 power plus y to the minus 1. And that simplifies to be 2 plus 2y to the negative 1/2 power plus y to the negative 1. Now, that doesn't look all that cool like that. All right. In fact, it looks kind of difficult. So what I would do is I would probably take out maybe y to the minus 1 if I wanted to simplify this and have positive exponents. So I would simplify this. I would take out the 1 over y, and that would leave a 2y plus a 2y to the 1/2 power plus 1. So now it looks like something I can work with, only because I don't have all those negative square roots, which can be stressful. Okay. All right, so now that is what goes in the square root. All right, any questions so far? I hope I didn't lose anybody with the algebra. Okay, so therefore I need to do my integral S. The integral, I think it was between 1 and 2, yes. 1 C and D of 2 pi x times the square root of 1 plus x prime of y squared dy. Okay. So S is equal to the integral a to, oh, I'm writing a to b. Come on, Dawn. Integral of 1 to 2 of 2 pi. For x, I thought I had y plus 2 to the root of y. And then I'm going to end up with the square root, and this is a biggie, of 2y plus 2y to the 1/2 power plus 1. All of that is over y. dy. Now, we can divide the square root of y out. S is equal to the integral from 1 to 2 pi. I'm going to get the square root of y plus 2, and then I'm going to get the square root of 2y plus 2y to the 1/2 power plus 1 dy. Okay, that's where I am. Okay, done. All right. Okay. Alrighty. Last problem. And I think the last problem, I go all the way to, oh no, that's not the last problem. But this will be the last problem.
So I have a question.
Yes. Kelsey?
I was just wondering, like, how do you know when you're done with the equation? Like, because each like example that we did, we stopped at different steps.
Okay, so notice, so this one I stopped at I finished the integral and I stopped because you guys don't know how to integrate that. This
Okay.
one, this one I stopped because you don't know how to integrate that yet. Whereas this one, I knew you knew how to integrate it, so I went all the way to the end. So this problem would be, and I guess I'll put it in here now for you. This problem would be set up, but do not solve. I will not give you anything that will get you to an integral that you don't know how to do, and then leave you hanging to figure out how to do it. Okay, so I have an idea of what you're capable of doing. I know that sounds unfair in a sense, but there's some integrals at this stage you should know how to do. I expect you to be able to do this integral, this one. Do the algebra and simplify it. This one, when you get to this point, I kind of know at the end of this integral, that's not something that anyone has taught you in your mathematical career. So I would say, set up but do not solve, which means once you put the integral in, you stop. If it's a setup but do not solve, don't spend your time trying to rack your brain trying to figure it out. And there's some of these that they'll have you set up and you cannot do the integral. There's some that I couldn't integrate because we don't have the tools to integrate it. So if you don't have the tools to integrate it, then that's what you would do. Does that help a little bit?
Yeah, that helps. Thank you.
Okay. All right, go ahead and update. You're gonna get on my nerves. My computer always wants to update in the middle of class when I'm looking at my notes. Okay, both of these are equally difficult. I will do this one. Okay. So y is equal to x cubed over 9 on the interval 0 to about the x-axis. So I already know if I'm doing that about the x-axis, I am using this one. Now, this one is not a setup, but do not solve. This one is one that you go all the way through to the end. So this one it would not say setup, but do not solve. I would expect you to complete it. Nope, I don't want you there. I want you here. Let you look over just a little bit. All right, so how do I start? Actually, I'll let y'all start working on this while I take roll. This is a good place to